Welcome back. Now, if you remember, by the end of the series of videos I had for exam 2, I said there's few more concepts on aldehydes and ketones and acids that we haven't quite got to. And so we're basically going to wrap those up in these series of videos. Okay, and the first of them is acetal or ketal formation. Okay, now you could start with an aldehyde or a ketone. What I have here is a ketone. You can see if it had been an aldehyde, then it would look like the same, but with a hydrogen on the end. This would have been an aldehyde, but I'm starting with ketone. Okay, the agenda here is we are basically going to write, see, if I have to write this in a more word sense rather than an actual reaction, we are basically reacting a ketone plus an alcohol in the presence of an acid. Okay, in a nutshell, this is what leads to the formation of an acetal. Okay, or also known as basically you won't have two alcoholic groups, that is two OH groups, but instead you end up with something like this on one of the carbons. Okay, this is called an acetal. Okay, now if this R had just been hydrogen, then that would be diol, but instead you have another group. Okay, so we're going to go look at it, but the key here is this: you're essentially reacting a ketone with an alcohol in the presence of an acid. Okay, this is a long mechanism. I don't expect you to remember every single step because I might ask the mechanism, parts of a mechanism, as a multiple choice question. So it's important you remember it, but don't try hard to memorize it. Okay, because if you actually try to understand it, it's easier than trying to memorize it. Okay, first step is, you all know that oxygen, okay, has two lone pair of electrons, right? Now, one of the lone pair of electrons, we've done this before, tries to abstract the hydrogen and in the process kicks the Cl out. Now, keep in mind, we've done this before several times. Whenever an element loses electrons, it gets a positive charge. But then the lone pair is now used to make a bond with the hydrogen, and then plus Cl minus. We still have that one electron left, right? One more pair left. Now, this is what is going to react with your alcohol. For instance, let's just take methanol, okay? I'm going to box it because this is one of the key steps in the acetal and ketal mechanism. Basically, this attacks this carbon, and in the process, this bond is going to go back to this oxygen. Okay, and whenever a bond comes back, it brings a negative charge, which neutralizes the existing positive charge, and that means we now have this situation. Basically, we got our lone pair back, but in the process, we've connected this oxygen with this carbon, but then the oxygen has to lose its lone pair of electrons. Now keep in mind, oxygen always has two lone pairs. It lost one of it, to bond with the carbon, and in the process, it made plus. So this step right here, folks, is very, very important. This is the really one of the most important steps in the ketal acetal formation. Okay. Now what happens? Now this is going to react with this right here. Will react with another molecule of water, because water is inevitable. Okay, water is inevitable. So that's going to react with this hydrogen, and in the process, this bond comes back. Again, like I said, don't try to photographically memorize this because that's really not going to help. Understand what I'm trying to do because I'm explaining it, and just try to make sense of that. Okay, and whenever a bond comes back, A positive charge is neutralized. This oxygen already had one lone pair. Now it's going to get the second lone pair back, and we get H3O plus. All right, we've added, remember I said we add two OR groups, right? In this case, the R is basically your CH3. So we've added one, we have to add one more, which means we got to do this cycle just one more time. And how do we go about doing that? Well, this again reacts with HCl. So what I'm going to do is I'm going to write this process here itself. Again, we're starting all over again from the same place that we started. Okay? So this is going to abstract the hydrogen, kick the Cl out. Now, if you remember, we started with a double bond. Here we have a single bond. But idea is essentially the lone pair is used. So this is a long mechanism, okay? But again, like I said, if you remember what is boxed, that's pretty good. And then try to recall what is happening with the rest of it, okay? So we have now another hydrogen and a positive charge. And basically we have this and CH3, okay? Plus Cl minus, obviously. Now what's the next step? Now this electron is going to come back here and kick this one out. Now keep in mind, in general in chemistry, anyone that has taken any upper level chemistry knows H2O plus is very, very unstable and it'd like to come off the molecule. Okay, and this is what is going to happen is basically you're going to generate this O plus CH3. Basically, we brought the lone pair to make a bond and kick this one out. So that's basically, this is what we have right now. Okay. Now this is again going to react with, you see this process looks very much like this. The only difference here is we had a hydrogen is now replaced by a CH3, but it looks exactly the same. Now we are going to react it with, I should have actually put two, this reacts twice, you know, it reacts with it twice. So same deal again here, this reacts and this comes back, okay? It's very, you know, it's very mechanistic in a sense that it's kind of the same thing happening over again twice. So, okay, plus, and then OCH3. Okay, now again, same deal. Water comes in, grabs this hydrogen, okay, and the bond comes back. And there we have our very final product. You see, we ended up with 2OCH3. The R could be anything. Say instead of CH3OH, if you could have also started with CH3, CH2OH. So basically, this was your product. Okay, let's summarize it. You know, let's say I give you this and you don't have the time to remember all this mechanism. Let's say I give you, this is the ketone, okay, plus HCl, and I give you 2 moles of CH3, CH2OH. All you got to do is write this molecule without the double bond O, but instead put a V, and on one side add a OCH2CH3. Just don't add the H here. Split it in 2 parts, and on the other side add OCH2CH3 as well. Now this is part of this. Basically, this is a short version of remembering this. This is called an acetal, okay, or ketal. Okay, if it's coming from a ketone, it's called ketal, but generally it's also known as an acetal. All right, that's a long mechanism. I don't think I've done anything this long in the entire course, over 330 and 335. So, you know, do your best, at least remember what's inside the box. What I would do is I could probably break each of this mechanism as multiple choice and ask you, I can purposely screw up some of the steps and ask you which step seems like the right one. All right, and then also I can ask you how I can how do you go from a ketone to an acetal? All right, so I got 3 more videos on this whole sequence, so stay tuned for the remaining 3 or 4 videos.